P10.4, momentum. So, firstly, what is momentum? Well, momentum is simply how hard something is to stop. And there are two factors that determine how hard something is to stop. And we'll go what those two factors are. So, two factors. How hard it is to stop something. And factor 1 is how fast, which we call the velocity, and that will be measured in meters per second. And the second factor is how much stuff you're trying to stop. So how fast is the stuff moving that you want to stop, and how much stuff do you have? And we call that mass, and that's measured in kilograms. So we've got velocity in meters per second, we've got mass in kilograms. And as we should know by now in physics, we can now turn that into an equation, because if they're the two things that affect it, and the bigger the velocity, the bigger the momentum, and the bigger the mass, the bigger the momentum, that tells me it's going to be a linear equation. So I can use the symbol rho for momentum, and a rho just looks like a sideways P, like that, and that equals mass times velocity. Okay, so let's give you an example. The car has a mass of 1,000 kilograms. It is travelling at 10 meters per second. So m equals 1,000, b equals 10. What's the momentum? Well, we can say that the momentum equals 1,000 kilograms times by 10 meters per second, which means that our car has a momentum of 10,000 kilogram meters per second. And you'll see that what I did there was I just combined the two units above because I'm combining the two factors. Okay, so that's it in its most basic form. But as we're physicists, we love conservation rules, and one of the most important conservation rules is conservation of momentum. And what that simply says is that the total momentum before equals the total momentum afterwards. Okay, now, and the key word here is total. And when we come on to the next one, when we come on to 10.5, you'll see some examples where a car's momentum might change in a collision, but all it's done is it's given that momentum to a different car. So if you add up the momentum of the two cars together, then it has stayed the same overall. It still nets out. And equally, the other example that you're given is an explosion. And if you think about an explosion, everything will fly off in every direction, and every bit will cancel each other out. Okay, but the main thing is that we, from this lesson, is that we understand this equation here. We understand that momentum is how hard something is to stop, and we know the law of conservation of momentum is to do with total before and total after. And in the next one, I'll go through some examples of how to use those facts that we just learned just now. Okay, so how hard it is to stop, combination of velocity and mass. Put in the equation, conservation is the total before, is the total after. Now we'll go through some examples.